Today, we're going to solve a mystery that's probably happening right in your own home. It's one of those things you've definitely noticed, but you might not realize there's some really cool chemistry going on right behind it.
You know the feeling, right? You're in the shower, you've got your bar of soap, and you're trying to get a nice, rich lather going. But it just won't happen. Instead, you get this sticky, kind of filmy scum. So what on earth is going on?
Well, your first thought might be, ugh, is the water dirty? But nope, that's not it. The real culprit here has a name. It's called hard water. And in this explainer, we are going to dive deep and figure out what that actually means.
So let's officially kick off our investigation. What exactly is this property of water that's sabotaging our soap?
Here it is, the official textbook definition. Water hardness is simply that property of water that stops soap from foaming up. It sounds super simple, but this one idea is the key to everything else we're going to talk about. And hey, if you're studying chemistry, this is absolutely a core definition you need to know.
All right, every good mystery needs its culprits, its troublemakers, and the case of hard water is no different. So let's unmask the chemicals that are actually causing all this fuss.
And there they are, our two main suspects, salts of calcium and magnesium. It's these dissolved minerals right here that are responsible for turning your soap into that gunky scum instead of the nice bubbly lather you want.
Now, here's where it gets really interesting. It turns out that not all hard water is created equal. There are actually two different types of hardness, and knowing the difference between them is the secret to figuring out how to fix the problem. This table breaks it all down perfectly. But here's the absolute key takeaway. Temporary hardness, which is caused by bicarbonates, you can actually get rid of just by boiling the water. But permanent hardness? That comes from chlorides and sulfates, and it is way tougher. You can't just boil it away. That's a huge distinction, especially if you ever see this on an exam.
So, like we said, for temporary hardness, the fix is pretty easy. When you boil that water, the calcium bicarbonate in it breaks down. See that little downward arrow next to CaCO3? That means it forms a solid precipitate. And guess what that is? That is the lime scale, the crusty white stuff you see building up inside your tea kettle.
Now, this might all seem like a minor annoyance in your bathroom, but the real-world impact of hard water is massive, especially when you start looking at big industries. Let's take a look at the real damage it can cause.
It is so much more than just wasting soap. That same scale that builds up in your kettle, imagine that clogging up giant industrial boilers. It makes them way less efficient. It can cause major damage, and in the worst-case scenario, it can completely block pipes. So yeah, this is a really big deal.
Okay, so we've defined the problem, we've identified our chemical culprits, and we've seen the damage they can do. So for our final act, let's talk solutions. How do we fight back and actually defeat permanent hardness? Well, one of the classic chemical methods is using something called washing soda. It's pretty straightforward, really. You just add it to the hard water, and it forces those troublesome calcium and magnesium salts to precipitate out as solids. Then you can just filter them away, and voila, you are left with soft water.
But there is an even more clever, more modern solution that's used in most water softeners today. It's called the ion exchange method, and it all comes down to making a really, really smart trade.
And this is the genius of it. Think of it like this. The hard water passes through a special material that acts like a magnet for those troublemaker ions, the calcium and magnesium. It grabs them and holds on tight. But in exchange, it releases totally harmless sodium ions back into the water. It's a perfect swap. The bad guys get captured, and the water comes out soft.
Oh, and here's a little pro tip for you. When you hear scientists or plumbers talking about how hard water is, they're actually measuring it. And the most common unit they use is something called parts per million, or ppm. That's just one of those little details that's great to know. So let's do a quick recap of our whole investigation. We started with the basic definition of hardness. We unmasked the causes, those calcium and magnesium salts. We learned the difference between the two types, temporary and permanent. We figured out how to remove them, and we saw the real-world disadvantages. If you can walk through these 5 points, you've totally got this.
You know, we started with a really simple, everyday problem, soap that won't lather, and we ended up talking about industrial boilers and ion exchange. It just goes to show you, chemistry is happening all around us, all the time, solving these little mysteries we might not even notice. Makes you wonder, what will you spot next?